Let's talk about data definition. All right, so for the first couple of weeks, we're going to be talking about representing all this data in the forms of what we be calling tables, right? And tables are what are going to be a collection of data points, right? And each data point, we're going to refer to them as records, right? So think of a table as a set, right? And each record being a point or a member of that set, right? And many of the operations that we'll be looking at as we progress are going to be based heavily on set theory, right? On being able to do all sorts of joins, right? And between the data sets, right? So the tables is going to be our data set. Rows are going to be are going to represent the records in each one of these data sets, and each column in the table are going to represent the different fields that describe that record, right? And each field is going to have any number of different data types, right? They can be either integers or strings or dates or enumerations, all different data types of each field. And schema, we're going to it's going to be a set of several tables, right? And we're going to say, well, what's the scheme of that database, right? And usually we're going to be referencing or referring to what are all the tables that describe the data of your database, right? In our university database, here we have the set of tables that describe our database. We have the students table, the department, course, section, enrollment, and then we have all the fields that describe each one of those, each record in that table. Notice that we have the primary key represented here in bold and italic, and then we have all the other fields not bolded. So we say that this is the schema of our database. Physically, this is what it will look like in a table, right? Here we have the different tables representing the different data sets, right? We have the students, we have the departments, the enrollments, the courses, the section, and here these arrows are conceptual, trying to capture the fact that all these records are somehow related to one another, right? Notice that the students have one of the fields is called major ID, and they have values that are representing they have the same values as the other columns in some other table, right? In the department 1, 2, 3, and 2, 3, 4. Now this could just be a convention, right? The convention is that we can all agree here as developers in this database when we're building this database that field major ID, the values over there are going to refer to values in the department ID. Yes. And by convention, we can all agree, and all our code would be based on this assumption, right? On all our understanding that this is what we mean, right? Now, we could go a little step further and tell this to the database. It says, "Hey, database, that is our intention," and make a formal statement to the database and says, and call that first column there DID, the department ID. We'll say that is the primary key, right? That is going to tell the database of our intention that somebody is going to refer to this field. Okay. Also, by making a primary key, it will enforce certain constraints. It will say, oh, well, if this is a primary key, then I'm not going to allow these fields to repeat. They're going to be unique, right? If I would not do that, right? If I don't enforce and say that department ID is a primary key, and then the database would allow me just fine to make those fields repeat, which would make no sense. Two departments that have the same ID, that makes no sense, right? And databases don't really care, right? Unless we tell them, right? So by declaring that department ID is indeed a primary key, it will enforce certain rules, right? And those rules, usually we call them constraints, right? It cannot repeat, right? And it will enforce certain things. For instance, this one, major ID, also we're going to say, not by convention, but we're going to tell the database, hey, database, that major ID field, it's a foreign key. And it's referring to that primary key over there. All right. By establishing this constraint, we are asking the database to enforce certain rules. For instance, what happens if I have two students, one of them is in chemistry, one of them is in the math department? What if I remove the math department, right? What if I try to remove the math department? Well, because I have told the database that department ID is a primary key, and I have a foreign key major ID that is referring to this department ID, the database would stop me. It says, no, you can't do that. You cannot remove the math department because you have other records that are dependent on it. You have children that are depending on their parent. You can't just remove the parent. Okay, that's nice. But if I remove, if I don't have any students referring to that department, then the database would say, okay, nobody is referring to this department. You can go ahead and remove the record. Okay, so that's nice, right? We can tell the database to enforce certain things. Same thing like we can enforce the fact that certain data, the year is an integer, right? And that certain things are dates or certain things are strings, right? If it's a date, the database won't let me put in there something that is not a date, right? Again, some validation, strong validation like you would expect in any good programming language, right? Except JavaScript, where you have all sorts of strong typing, and validation that allows you to capture these things early on, right? It doesn't allow you to make these errors.